Hi, and welcome to this video on molar mass of a compound. In this video I'm going to show you how to calculate the molar mass of a compound, and I'm also going to show you how to use the molar mass of a compound as a conversion factor. Now, in a previous video I discussed how we could calculate the molar mass of an element by knowing the mass of the element and also knowing the amount of the element in moles. And I pointed out how the numerical value of the molar mass of an element is exactly the same numerical value as the atomic mass of an element, except that when we talk about the atomic mass of an element, it has units of AMUs, which is atomic mass units, per single atom, whereas when we're using the molar mass of an element, it's the mass of 1 mole of the element, so Avogadro's number, or 6.022 10 to the 23 atoms of that element, having a mass unit of grams. We could also calculate the mass of a compound. Now, if we're talking about the mass of a single molecule of a compound, we would refer to that mass as a formula mass. So the formula mass of a compound is the mass of a single molecule, or if the compound's an ionic compound, the mass of a single formula unit in atomic mass units. And let's consider two different compounds, water versus sodium chloride. Now, water is a molecular compound, whereas sodium chloride is an ionic compound. And the smallest component of each of these compounds is somewhat different because there are different types of compounds. In the case of water, the smallest unit of water that still has the properties of water is a molecule of water that contains 1 oxygen atom and 2 hydrogen atoms. Now, for sodium chloride, the smallest unit of sodium chloride is called a formula unit. So the formula unit of an ionic compound can be thought of as the smallest electrically neutral collection of ions in the ionic compound. So to calculate the formula mass of a compound, all you need to do is add up the individual atomic masses of the species composing either the molecule or the formula unit. In the case of water, it's composed of 2 hydrogen atoms, and each hydrogen atom has an atomic mass of 1.01 AMUs, plus the mass of 1 single oxygen atom, which has a mass of 16 AMUs. And so we can see that the formula mass of a molecule of water is 18.02 atomic mass units. Now, the formula mass of a formula unit of sodium chloride would be the mass of 1 sodium cation, which would be 23 AMUs, plus the mass of 1 chloride ion, which would be 35.45 AMUs. And we get a formula mass of 58.45 AMUs per formula unit of sodium chloride. We can also talk about the molar mass of a compound, which would be the mass of 1 mole of molecules, or 1 mole of formula units, in a mass unit of grams. And in order to get the molar mass of a compound, all we need to do is add up the individual molar masses of all the species composing the compound. So let's consider, for example, the molar mass of carbon dioxide. So 1 mole of CO2 molecules would be the mass of 2 moles of oxygen atoms, coupled with the mass of 1 mole of carbon atoms. Now, the molar mass of oxygen is 16 grams per mole, and there's 2 moles of oxygen, added to 1 mole of carbon atoms, which have a molar mass of 12.01 grams. And we can see that the molar mass of carbon dioxide is 44.01 grams per mole. So in other words, if we wanted to count out 1 mole of carbon dioxide molecules, what we would have to do is weigh out a mass of 44.01 grams. Now, most importantly, molar mass can be used as a conversion factor, and it can allow us to convert the mass of a compound into an amount of compound in moles. And to illustrate how to use molar mass of a compound as a conversion factor, let's consider the following problem. How many oxygen atoms are there in 25 grams of carbon dioxide? And the molar mass of carbon dioxide is given as 44.01 grams per mole. So if we try to approach this problem as a conversion factor approach, we would start off with our starting units, which would be grams of carbon dioxide, and we want to convert those units from grams of carbon dioxide specifically into a number of oxygen atoms. Now, notice how we're going from carbon dioxide to a specific component of carbon dioxide, which in this case would be oxygen. And we want to convert a mass into a number of atoms. So let's start off with our starting amount of 25 grams of carbon dioxide. We're going to convert that mass of carbon dioxide into moles of carbon dioxide by using the molar mass of carbon dioxide as a conversion factor. So by doing this conversion, what we've now done is converted the mass into an amount of CO2, and then once we have the amount of CO2, we can then convert it into a number of actual molecules by using Avogadro's number. Once we have the number of molecules of carbon dioxide in 25 grams of carbon dioxide, we can then use the fact that 1 molecule of carbon dioxide contains 2 oxygen atoms. So what we're actually doing here is that we're using the chemical formula and the subscripts in the chemical formula as a conversion factor to convert number of molecules of CO2 into number of oxygen atoms. So if we do the calculation 25 divided by 44.01 times Avogadro's number times 2, we now calculate that the number of oxygen atoms in 25 grams of carbon dioxide is 1.89 times 10 to the 24. Now we could have done these calculations in a slightly different order if we think about the fact that the chemical formula can also be thought of as molar relationships. We would still start off with our 25 grams of carbon dioxide and convert grams of carbon dioxide into moles of carbon dioxide. But this time what we would do is we would use the fact that in 1 mole of carbon dioxide there are 2 moles of oxygen atoms. And then once we have number of moles of oxygen atoms, we can then convert moles of oxygen into actual number of oxygen atoms by using Avogadro's number. And we would still calculate the same exact answer as the previous slide. It's just that our math is being done in a slightly different order. Now which method you decide to use is totally up to you, but just make sure that you use your units properly, and as long as you use your units properly and you see that they cancel in a proper fashion, you'll be guaranteed to get the right answer. Okay, so now that you've watched this video, you should be able to calculate the molar mass of a compound, and you should also be able to use molar mass of a compound as a conversion factor in your calculations.